Hi everyone, Christian, I'm putting you in charge to press pause when I say to press pause, and everybody leave Miss Al-Halabi alone and let her relax. She's got a little baby at home, she needs to relax. Okay, so here's your aim for today. What is the second derivative test? Here's your do now to find all maximums and minimums for y equals 3x squared minus 3x plus 2. So Christian, can you press pause and then time it for 5 minutes, and then you should restart it. Okay, so I hope Christian did what he was supposed to do, and now I'm going to go over the solution for that. Now I know you're saying you already know how to do this. Why am I doing it? You'll say. Okay, so to find max and mins, we need to find the derivative. So we get that, and we're going to set it equal to 0. Okay, so that means that there is a critical point at x equals 1/2. So we're going to make our wiggle graph, and we're going to put 1/2 on there. And then we're going to try values to the left and the right. So for example, we could do y prime of 0, and we get -3, so it's a negative up there. And then we could do y prime of 1, and then we'll get 3, so that's a positive. Okay, so what does all this information tell us? I'm just going to go to a new screen. Okay, I'm just going to look at the wiggle graph. Okay, so we have this and this. Alright, so this is just review really. So we can see that f is decreasing. Whoops, Miss Al-Halabi's going to yell at me if I use the wrong brackets. Is decreasing from -infinity to 1/2. And f is increasing from 1/2 to infinity. Okay, and because it decreased and then it increased, that means there is a min. So we know that there is a min at x equals 1/2. Okay, so that's a perfectly fine way to do this. I'm just going to show you another way to do it called the second derivative test. So I'm going to a new screen. Okay, so this is what we know so far. This is the original, and this is the derivative. Okay, so here's your new way. You find the second derivative. So the second derivative would just be 6. Okay, and there's a rule that says if the second derivative is greater than 0, and that's the case here because 6 is bigger than 0, then there's a min. If it had been a negative number, so that f double prime, I think I might have said f prime, it's f double prime of x is less than 0, then there's a max. Okay, so in this case, y double prime was greater than 0, so therefore there's a min. So let's say the question asked you, where is the extrema, and make sure you justify your answer. You would write, there is a min by the second derivative test y double prime is greater than 0. Okay, so this would explain that there is a min. Okay, I'll wait for a minute so you can copy, and then I'll explain like why does this even work. Okay, so you should just be copying all this. And I also just want to point out that in this case, y double prime was a constant. But if y double prime had had a variable in it, then you would have put an x value in there to see if it's a max or a min. So I'll explain. If you guys need more time, Christian can pause, but I'm going to move to the next screen. So just as an example, if we had gotten that y double prime equals 6x, and then you set your derivative equal to 0, and in this case we got that x equaled 1/2, then you would do y double prime of 1/2 equals 6 times 1/2, which equals 3. 3 is greater than 0, therefore there's a min at x equals 1/2. Okay? Now we already knew there was a min at x equals 1/2 because we used the wiggle graph to find that. But if it's just a constant, then you don't have to plug anything in. So you might be saying, why would you even want to use this? Well, sometimes it's really annoying to use the wiggle graph, and when you find the second derivative, it sometimes is a nice easy number, like 6x for example, and sometimes it's easier to work, just to work around that. I mean, either one works, but just want to point out that if you're justifying it on the AP exam, you must say by the second derivative test. Okay, so I just want to explain why does this work. Okay, so we talked about concavity, and we said that if f double prime is greater than 0, then f is concave up. Okay, so think about this. If you're concave up, you would look something like this, and there has to be a min. So if it's greater than 0, meaning it's concave up, there's a min. I know that's kind of counterintuitive because you're going to think, oh, if it's bigger than 0, it's a max. But no, it's the opposite. Okay, and by the same measure, if f double prime is less than 0, then f is concave down. And what does concave down look like? It looks like this. And that means there's a max. Okay, so if the second derivative is less than 0, then there's a max. If the second derivative is greater than 0, then there's a min. Okay, so I'll give you a minute to get that all copied, and then you're going to try a problem all by yourself. Okay, if we need more time, then Christian is going to pause this, but I'm moving on. Okay, here's a new function. And what I'm going to ask you to do is to find all max and mins in two different ways. So you can see how they both work. Okay, so one way is going to be by using the wiggle graph. And the second way is going to be by using the second derivative test. Okay, so Christian is going to pause this once you copy down the function, and then I think 10 minutes should be good, Christian, and then put it back on, and then you guys can all see the solution. So make sure you pause this so you don't hear the solution. Okay, so we're back. I'm going to change colors. Let's do a purple. Okay, so this was the function. Okay, and I'm going to first do it with the wiggle graph. So we take the derivative, and then we're going to set that equal to 0. Okay, we'll factor out a 4x. Okay, so we get x equals 0, we get x squared equals 6, so x equals plus or minus radical 6. So there's actually 3 different things here to work with. So here's our wiggle graph. We're going to substitute into the derivative. We have negative radical 6 on there, 0, and radical 6. So you're going to try different values. I had tried f prime of negative 4. And I got a negative number, so that's negative. I did f prime of negative 1. That gave me a positive number. F prime of 1 gives me a negative number. And f prime of 3 gives me a positive number. Okay, so I'm just going to erase this work over here, just to make some room. I'll change colors. And what have I discovered? That it's going from negative to positive, so that means there is a min at x equals negative radical 6. Okay, I was positive and then I was negative, so I was a max at x equals 0. And I was negative and then positive, so there's a min at x equals radical 6. Okay, so that's how you would do it just if there is a wiggle graph. Okay, I'm going to go to the next screen. Let's get a nice new color. How about this blue? Okay, so start from the beginning. Here's the original function. Here's my first derivative. And I still have to set it equal to 0 because I need to know what points I'm testing. And we already know that we're going to get three answers. We're going to get x equals 0, x equals plus or minus radical 6. Okay, so what we're going to do different this time is, so what we have to figure out is, are these maxes or mins? So rather than using the wiggle graph, we're going to find the second derivative. Okay, so the second derivative is going to be 12x squared minus 24. Okay, and then we're going to test these three values. We're going to do y double prime of 0. And that will give you 0 minus 24. You don't even care what the number is, you just want to know if it's positive or negative. And this is clearly negative. So therefore, at x equals 0, there's a max. Because if the second derivative is less than 0, remember it's the opposite, then there's a max. Okay, so that's one answer. I'm just going to go back to the other screen for 1 minute. And you can see, yeah, there was a max at x equals 0. So far it matches. Okay, then we're going to do y double prime of negative radical 6. And when you substitute that in, you are going to end up getting a positive number. Right, because when you put, you're going to put it into here. Okay, so therefore, at x equals negative radical 6, there's a, so the second derivative is greater than 0, therefore there's a min. Okay, let's double check this. So at x equals negative radical 6, there was a min. We have one more to try. Y double prime of positive radical 6. And when you put that in, you're also going to get a positive number. And therefore, at x equals radical 6, there's a min. So let's just double check that. At x equals radical 6, there's a min. Okay, so you can see it works for both ways, whichever way you like better. You are going to have homework. And in case you have extra time, I'll tell you what the homework is right now, so you can get started on that. But if this took the whole period to do, which probably it did not, then you can get started on it now. Okay, change colors for the last time. I'll do black. Okay, so if here's question 1 from the homework. If y equals 4x to the 4th minus 4x squared, you need to find all the maxes and mins. It's a multiple choice question, so make sure that you actually look at the sheet that's on Pupil Path. And question number 2 is, if the function is y equals x cubed plus 6x squared minus 15x plus 13, find the inflection points. Okay, that means the x and y. And that's also multiple choice, so make sure that you look at the sheet again. So that's your homework, and you can leave that up, and then Christian, you could pause it so everyone can start working on the homework, and then that's it, we're done.